So we'll have two examples to start with. The first one is determine whether the following functions are bijective. If not, restrict the domain to make the function bijective and state the domain and range. A, here we'll do, for the first one, f of x is equal to x minus 1 over 2x plus 3. And then B, f of x is equal to, let me go for quadratic here, is equal to 3x squared plus 2x minus 1. Solution. So we'll start with a note. To check for bijectivity, we check if the function is one-to-one and onto. Simply mean injective and surjective. So this is one-to-one, this is onto. So that's the target. And then just to remind you, we also say that to check if f is one-to-one, just check if f of a is equal to f of b implies a is equal to b. To check if f is onto, you just check if f inverse of a is equal to f inverse of b implies a is equal to b. So I've got these two ways. So combined, we are checking if the function is bijective. So now let's go to part one and check if our function is bijective. So a is f of x is equal to f of x is equal to x minus 1 over 2x plus 3. X minus 1 over 2x plus 3. So we first check if it's one-to-one. Well, we say f of A is equal to f of B. This is the same thing as f of A. In f where there is x, you substitute A. So we have A minus 1 over 2A plus 3 is equal to A B minus 1 over 2B plus 3. And then we cross multiply. So we cross multiply. We have A minus 1. We have 2B plus 3 is equal to B minus 1 and 2A plus 3. Then we expand. So we get 2AB plus 3A minus 2B minus 3 is equal to 2AB plus 3B minus 2A minus 3. So because negative 3 is on the left and another negative 3 is on the right, if we move one of them to either side, we'll have a 0 there because we'll have 3 minus 3. We can just cancel them out. The same thing is happening to 2AB and 2AD. Then now we choose which side to check A or B. So we move the A's to the left and the B's to the right. So we'll move this negative 2A to the left. It will become positive 2A is equal to 3B plus 2B. So that we get 5A is equal to 5B. Divide by 5, divide by 5. Then we'll have A is equal to B. What does this tell us? This implies that F is 1 to 1. We're remaining with one thing to check if it's onto. To check if it's onto, we get the inverse. So we now find F inverse. So we let y be equal to f of x, and so for x. So say y is equal to x minus 1 over 2x plus 3. So I can put over 1 here so that when I say cross multiply, it makes sense to everyone. So this is giving us 2x plus 3 multiplied by y is equal to x minus 1. We expand, we have 2xy. Excuse. We have 2xy plus 3y is equal to x minus 1, which implies that since we are solving for x, so we can take this x the other side and the 3y the other side. So we have 2xy minus x is equal to negative 1 minus 3y. So we get x and then 2y minus 1 is equal to minus 1 minus 3y. Solving for x, we will divide by 2y minus 1 divide by 2y minus 1. So we get x is equal to negative 1 minus 3y over 2y minus 1. So the inverse, so f inverse of x is equal to negative 1 minus 3x over 2x minus 1. So this is the inverse. We now check if we want to check. So we check if f is onto. So we say f inverse of A is equal to f inverse of B. So in F inverse, we substitute A first. We get -1 minus 3A over 2A minus 1 is equal to -1 minus 3B over 2B minus 1. Then we'll get -1 minus 3A. 2B minus 1 is -1 minus 3B. 2A minus 1. We expand, we get -2B plus 1 minus 6AB plus 3A is equal to -2A plus 1 minus 6AB plus 3B. So again, +1 and +1 will cancel, and minus 6AB minus 6AB will cancel. Then we'll move A's to the left. So we'll have 3A plus 2A is equal to 3B plus 2B, giving us 5A is equal to 5B, which implies that A is equal to B when you divide by 5. Therefore, F is both 1-to-1 and onto. Hence, F is bijective. Because it's bijective, let's now find the domain. So the domain of F is X must be a real number, except for its denominator becoming 0. So we equate the denominator 2x plus 3 to 0. And so for x again, we get 3 divided by 2. So we get x is equal to 3 over 2. So we are saying in the domain, x should not be equal to 3 over 2. Because if that happens, then the denominator is going to be 0. If the denominator becomes 0, the function becomes undefined. Joseph?
Sir,
Hello?
when the 3 moves to the other side, won't it be negative?
Yeah, it will be negative. Thank you. So it becomes negative there. So this is not supposed to be negative. Okay, good. Then now we go for the range. The range of F, we are saying Y, a real number. Joseph, the hand is up. Okay. So Y, a real number, such that we now go for the inverse. 2x minus 1 and equate it to 0. So for x, divide by 2. So x is half. So we say y should not be equal to 1 over 2, but it can be any other real number. This becomes the range. Well, easy to do because the function is bijective. So we also note one thing here. Please note that you may actually be asked to check if a function is onto. We are used to checking if a function is one-to-one. Okay. Now we can be asked to check if a function is onto. That's why here I've taken the long way of checking if the function is onto. If they say check if the function is onto, this is what you are supposed to do. You find the inverse. You find the inverse. Okay. Find the inverse. After you find the inverse, check that the inverse is one-to-one. So you first find the inverse. After you have the inverse, check if the inverse you have found is 1 to 1. If the inverse is 1 to 1, then the function is on. That's why I've stated here. To check if f is onto, check if the inverse of a equal to the inverse of b implies that a is equal to b. So you are checking if the inverse is 1 to 1. Okay. Now, let's go for a case where we may fail to have the function 1 to 1. And then, 1 to 1, that makes it fail to be bijective. Then we force it not to be bijective. So let's do b. So b, we have f of x is equal to, there's the hand up. Please, you can ask if there's a question. Okay. Well, to check if this function is bijective, we start the normal way. We check if, so we check if f of a is equal to f of b implies that a is equal to b. And then we find the inverse. So we check f of a in this case is 3a squared plus 2a minus 1, which is equal to 3b squared plus 2b minus 1. So the ones will go, and then we remain with 3a squared plus 2a is equal to 3b squared plus 2b. So what does this tell us? Well, because now we have gone a bit detailed in functions, so we can complete the square on both sides and see if we're able to get a and b and how we get it. So we complete the square on the left, we have 3 and then a squared plus 2 over 3a. We'll be doing the same on the right. We have 3 b squared plus 2 over 3b. We first attend to a, we first attend to the coefficient of a squared and the coefficient of b squared. Then now we move to, here I'm just computing the square, the normal computed square that we know. So then we move to the coefficient of a. So I'll have a squared plus 2 over 3a plus, I divide, so I'm dividing 2 over 3 by 2, which is the same thing as multiplying 2 over 3 by 1 over 2. So this is 1 here, 1 there. So we get 1 over 3. So instead of me doing the 2 over 16, I'll do 1 over 3, and then I'll square it. 8x squared to 3x squared. Is it 8? No, this is 3, not 8. It's 3. So it's supposed to be 3x squared. Okay. So when you add, you subtract the very thing that you add. You subtract it squared. Okay. We do the same on the right. So we have 3 b squared plus 2 over 3 b plus 1 over 3 squared, and then minus 1 over 3 squared. Then what does it become? So now we have 3, and then we get a plus 1 over 3 squared minus, we expand this one now, it becomes 1 over 9. Because 3, we get b plus 1 over 3 squared minus 1 over 9. Then expand. There's a hand from Mavis. That's the question. Okay, so we hear you when you talk. Then we now expand. Instead of expanding, since these are equations, you can divide by 3 and divide by 3. So that this 3 can cancel, this 3 can cancel, and then remain with a plus 1 over 3 squared minus 1 over 9 is equal to b plus 1 over 3 squared minus 1 over 9. So 1 over 9, 1 over 9 will cancel. We remain with a plus 1 over 3 squared is equal to b plus 1 over 3 squared. We are solving for one of them, so if we square root, then we'll get a plus 1 over 3 what has happened? Someone can't see the right thing. You should be able to see now. Okay, so this is going to be equal to plus or minus b plus 1 over 3. So this means that a is equal to negative 1 over 3 plus or minus b plus 1 over 3. So, so this means that this function f is not 1-to-1. Because the two conditions must be satisfied for a function with bijective, and we have seen that it's not 1-to-1. This means that f is actually not bijective. F is not bijective. Because f is not bijective, the question said, should you find a function is not bijective, restrict the domain to make the function bijective, and then state the new domain and the range. So this means that now that the function is not bijective, it's obvious it has to do with the domain. So we restrict the domain of this function. Look at the function. The domain of this function is all real as it stands there. Now, because it's all real, we have found it to be not bijective. So now I want to force it to bijective. So how do we force the function? It is f of x is equal to 3x squared plus 2x minus 1. Well, we've computed the square. So we've computed the square of this function. And hello. Okay. So I've computed the square without 1. So what we do is we just bring back 1, and then in the complete thing, in this piece here, that is complete, we just bring back 1. So 3 and then x plus 1 over 3 squared minus 1 over 9 minus 1. So now expand 3 x plus 1 over 3 squared minus 1 over 3 minus 1. So I can put these together so that we get 3 x plus 1 over 3 squared minus 4 over 3. How do you add minus 1 over 3 minus 1? I think I should comment here. I marked so many questions wrong on just this addition. When you take 3 down, then you say 3 in itself 1. 1 by negative 1. You write negative 1. 1 into 3, 3. By negative 1, you write negative 3. Then it becomes negative 4 over 3. And not the opposite. I saw something like negative 1 over 3 minus 1 over 1 is equal to, you write 3 down, put the minus, open, and then you write 1 minus 3. It ends up being negative 2 over 3, which makes it positive 2 over 3. Now imagine you're computing the square. You get it wrong at this point, then you go and sketch, it will be wrong sketch. So you get 0 out of the whole sketch. You get the minimum value or maximum value to the wrong one because of this same value here. At least I've commented on that one. I'm safe going forward. Grace?
Sir, I'm behind where you introduced one of the completing square thing you got from the other one. I'm lost from there.
Here?
Yes.
Where are we? On this part?
Yes, sir.
So this is like doing the completing square method. Where I complete the square of 3x squared plus 2x minus 1. So to avoid the whole procedure, since we've already done the procedure here, we just pick the final thing. But remember that as we pick the final thing, we had cancelled 1. So that's why we just brought back negative 1 because we had cancelled it. The procedure would be the same up to here. Okay. Then now,
yes,
when we reach here now, we are saying, oh, this function has its minimum. It has its minimum value at negative 1 over 3, comma negative 4 over 3. What this means is if I was to sketch at negative 1 over 3, comma negative 4 over 3 here, the function will have a minimum. Okay, so it will be of this nature. I have this type of function. So what makes this function not to be one-to-one is because of this behavior of giving the same value for this number and for this number, the same value for this number and for this number here. Mangala. So now to make it bijective, we just cut the domain. We'll cut it at the line of symmetry here. So we'll cut it. Hello?
Sorry for taking you back, but please, can you explain again the completing square part?
Okay. So in this video, we just have like 3 minutes remaining. So what we'll do is, when we get back, we'll do another example where I will do the completing slowly so that you can see how to complete. So I'll take care of it in the next video. So here, let's just pick now, how do we restrict the domain in the remaining 2 minutes? So we say the domain of this function now becomes, you cut it on the line of symmetry and pick either side. So we'll say, let it be x a real number such that x is greater or equal to negative 1 over 3. So I've picked the right. I've just picked this part here. So the values of x that will be used are only the values of x from this number going this side. So because that will be the case, it means that we won't have two values of x giving us the same number. We've cut that thing of repetition on the line of symmetry. But the range of the function will remain the same. The range will remain y, a real number, such that y is greater or equal to -4/3. This means that both the domain and range of the restricted quadratic function comes from the chaining point. So this is the minimum chaining point, the minimum point, and not the value. So the domain comes from the x value, the range comes from the y value. Okay. So for those that will just watch the video, I've received so many messages on email trying to get my line. I changed the number to 0973 825655. So you can reach me here for any questions that you face after watching this video. Okay, so we can rejoin and then I'll attend to all the questions because we'll do another example similar to this one so that we can have enough time now for you to ask questions.